Module 3, Unit 3.1, Exercise 9A.
Hey Mark, how's your physics study going?
Hi, Anna. It's going well. I've been trying to wrap my head around Newton's laws of motion. They're pretty fundamental, but I still get confused sometimes.
I know what you mean. Let's go through them together. Newton's laws are really important, and once you understand them, they make a lot of sense.
Sounds good. Let's start with the first one.
Sure. Newton's first law is the law of inertia. It states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force.
Right, so basically, things don't change their state of motion unless something makes them, like friction or a push.
Exactly. For example, if you slide a book across a table, it eventually stops because of friction. Without friction, it would keep moving.
Got it. What about the second law?
Newton's second law is about acceleration. It states that the acceleration of an object depends on the mass of the object and the amount of force applied to it. The formula is F equals m times a, where F is the force applied, m is the mass, and a is the acceleration.
So, if I push two objects with the same force, the one with less mass will accelerate more?
Exactly. And if you push the same object with more force, it will accelerate more. It's all about the relationship between force, mass, and acceleration.
That makes sense. What's the third law?
Newton's third law is the action-reaction law. It states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. If you push on a wall, the wall pushes back with an equal force.
So when I jump off a boat onto a dock, the boat moves in the opposite direction?
Yes, that's a perfect example. Your push off the boat creates an equal and opposite force, making the boat move backward.
Thanks, Anna. This really clears things up. Newton's laws explain so much about how things move and interact.
They really do. Once you understand these basics, you can start applying them to all kinds of situations in physics. Keep practicing, and it will all click.
I will. Thanks for the help, Anna.
Anytime, Mark. Good luck with your studying.
Thanks. See you later.
See you.
Module 3, Unit 3.2, Exercise 7.
Hey Lisa, how's your learning adventure?
Hi, David. It's pretty intense. You know, Einstein's theory of relativity is fascinating, but a bit mind-bending.
I know what you mean. Relativity can be challenging, but it's really interesting once you get the hang of it. Are you looking at special or general relativity?
Mostly special relativity for now. General relativity seems even more complex.
Let's start with special relativity then. The basic idea is that the laws of physics are the same for all non-accelerating observers, and the speed of light in a vacuum is constant, regardless of the motion of the light source or observer.
Right. I've read about that. It leads to some pretty strange consequences, like time dilation and length contraction.
Exactly. Time dilation means that time passes more slowly for an object in motion compared to an object at rest. For example, if you travel near the speed of light, you'd age more slowly compared to someone who stays on Earth.
That's so weird to think about. And length contraction is when objects moving at high speeds appear shorter in the direction of their motion, right?
Yes, precisely. An object moving at a significant fraction of the speed of light will appear compressed along the direction it's moving. It's all about how space and time are interconnected.
I've also read about the famous equation E equals mc squared. How does that fit into special relativity?
That's a key part of it. E equals mc squared shows the equivalence of mass and energy. It means that mass can be converted into energy and vice versa. This concept is crucial in understanding nuclear reactions and other high-energy processes.
That's amazing. What about general relativity?
General relativity deals with gravity. Einstein proposed that gravity is not a force between masses, but rather the warping of spacetime caused by mass and energy. Massive objects like stars and planets curve the spacetime around them, and this curvature affects the motion of other objects.
So objects move along the curves in spacetime created by massive bodies.
Exactly. This explains why planets orbit stars and why light bends around massive objects. It also leads to phenomena like black holes, where the curvature of spacetime becomes so extreme that not even light can escape.
That's incredible. No wonder it took so long for scientists to accept these ideas.
It's definitely groundbreaking. Einstein's theories have been confirmed by many experiments and observations, from the bending of light during a solar eclipse to the detection of gravitational waves.
Thanks, David. This really helps clarify things. I still have a lot to learn, but I'm starting to get a better grasp of relativity.
You're welcome, Lisa. Just keep studying and asking questions. Relativity is a complex topic, but with time and effort, it'll start to make sense.
I will. Thanks for the encouragement.
Anytime. Good luck with your studies.
Thanks. See you later.
See you.
Module 3, Unit 3.4, Exercise 8.
Hey, Jake. How are you getting on?
Hi, Emily. I'm nice, thanks. Just trying to stay on top of everything. How about you?
Same here. I've been trying to focus more on a healthy lifestyle lately. It's tough with all the studying, though.
That's great. What kind of changes have you made?
Well, I've started meal prepping on weekends. It helps me eat healthier throughout the week instead of grabbing fast food.
That's smart. I've been trying to cook more at home, too. It's cheaper and healthier.
Exactly. Plus, I've been making an effort to exercise regularly. Even just a 30-minute walk each day makes a difference.
Yeah, I've been going to the gym a few times a week. It really helps me clear my mind and stay focused.
I know what you mean. Exercise is a great stress reliever. I also try to get enough sleep, which can be challenging with our schedules.
Tell me about it. I've been trying to go to bed at the same time every night. It's tough, but I feel so much better when I get enough sleep.
Me too. I also make sure to stay hydrated. I carry a water bottle with me everywhere.
That's a good habit. I should do that more often. I've noticed that drinking enough water helps with concentration and energy levels.
Definitely. And I've been trying to manage my time better to avoid last-minute cramming sessions. It's less stressful, and I can retain information better.
Good point. I've been using a planner to keep track of assignments and deadlines. It really helps me stay organized.
That's a great idea. Balance is key. It's important to make time for relaxation and hobbies, too.
Absolutely. I've been trying to set aside some time each day to read or just unwind. It helps me recharge.
Same here. Mental health is just as important as physical health. I've been practicing mindfulness and meditation as well.
That's awesome. I've heard good things about meditation. I should give it a try.
You definitely should. It helps with stress and focus. Overall, small changes can make a big difference in leading a healthier lifestyle.
I agree. Thanks for the tips, Emily. It's inspiring to see how you're balancing everything.
Thanks, Jake. It's a work in progress, but it's worth it. Let's keep each other motivated.
For sure. We've got this. See you around, Emily.
See you, Jake.